Hi everybody. In this video I will be covering learning target 15. This one specifically we're looking at critical numbers of a function and also the extrema of a function on a certain interval. Critical numbers are a really important part of this class and also just a part of your future math classes and also like physics classes too. Once you start doing physics classes where you learn about functions of position and then its subsequent derivatives of velocity and acceleration, critical numbers are an important physical phenomena of like when something may be changing direction or changing speeds. So it's really good to get a mastery of this early on to help for your future engineering career. So we need to find critical numbers of this function f of x. And critical numbers, sorry for my really bad handwriting, I'm trying not to take too long to write this. Critical numbers will occur when f prime of c, the derivative at some point is equal to 0, and, or f prime of c doesn't exist. Now, this is true, but also, I hope you guys noticed this right here. Remember that critical numbers must lie in the domain of the function. So you may find critical numbers using these definitions over here, f prime of c equals 0, f prime of c doesn't exist. But for that to hold true, it has to be in the domain of the function, f of x. So keeping this in mind, let's go ahead and solve this problem. So our first step will be taking the derivative. It looks like for this one, I'm going to have to use the quotient rule. So we'll have our low function, x minus 3, times the derivative of the high function, 6x, minus the high function, 3x squared, times the derivative of our low function, which will just be 1. All of this is going to go over our low function squared. So x minus 3 squared. Now I'm going to go ahead and try to simplify this numerator a little bit to make it easier to solve for our critical numbers. So distributing this out, let me use a different color, sorry. Distributing this out, I will have 6x squared minus 18x minus a 3x squared. That comes from this right part right here. Remember that all of this is over x minus 3 squared. I can simplify that numerator just a little bit more by writing it as 3x squared minus 18x over x minus 3 squared. Now, let's look at our conditions. We need to find when f prime of a number equals 0 and when f prime of a number does not exist. So thinking back to the beginning of this class, we learned about the domain of like different functions. We can find when a function does not exist, and then we can find when a function equals 0 just by setting it equal to 0 and solving for the subsequent x values. So first, I'm actually going to name this rule 1, rule 2. First, let's solve that first condition. So what we're going to do is we're going to set the numerator, 3x squared minus 18x, equal to 0. Because if this numerator equals 0, then that whole derivative function is equal to 0. And then here we can see that we can just factor out a 3x. So I'm going to do that. And that leaves me with x minus 6 equal to 0. And from here, we have 3x equals 0 and x minus 6 equals 0 as like our two little subsequent terms. So from this one, I'm gathering that x equals 0, and from here, x equals 6. Let's mark these for now. And we'll get back to them and we have to do a quick little check, which I alluded to earlier. But for now, let's look at this second condition. F prime of c does not exist. Since we're dealing with a fraction right here, 3x squared minus 18x over x minus 3 squared, you may remember that this f prime of x does not exist when the denominator is equal to 0. That means we can set this denominator equal to 0 and solve for x. So 3 of x minus 3 squared, we'll set this equal to 0. Taking the square root of both sides, we'll just have x minus 3 equals 0 because the square root of 0 is 0. And then we have that x equals 3. So now, when you look at this condition that we're given here, that critical numbers must lie in the domain of the function. And we'll take a look at all of our points to see if they in fact satisfy that. So we have x equals 0. Well, actually first, sorry, let's consider on the side here, f of x. We need to find the domain of this. Since it is a fraction, as I just talked about earlier, we need to see when the denominator is equal to 0. So x minus 3 equals 0, x equals 3. This is not in the domain of f of x. So now we can go through our given points, our given potential critical numbers that we solve for. Notice I said potential, because these aren't critical numbers yet, because we haven't passed that condition that they lie in the domain of the function. So the first one, x equals 0, it's not equal to 3, so that's fine, that's good. X equals 6, same deal. But this one over here, x equals 3, gotta give that a no, because we showed here that it's not in the domain of the original function, f of x. That means our answer is x equals 0 and x equals 6. Next, we're asked to find the absolute maximum and minimum values of f of x on the interval -2 and 2. And it should be noted here that we have a couple potential values that we're going to consider for this, and that's these critical numbers. So x equals 0 and x equals 6. Notice it says absolute maximum and minimum values. That means we can count the intervals as well, their potential values. -2 and 2. And I'm just going to mention that these are potential candidates. But you may have noticed I have x equals 6 in there, and our interval is from -2 to 2. So I'm going to cancel out that 6. So now we're just left with 0, -2, and 2 as potential candidates. So since we're solving for an absolute max, absolute min, the way we could find these maximum and minimum values is by plugging into our function. So that means we'll want to have solve for f of 0, f of -2, and f of 2. First, we have f of 0. We plugged it in. We have to our original f of x function. We'll have 3 times 0 squared over 0 minus 3. And this just equals 0. Next, we have -2. So I have 3 times -2 squared over -2 minus 3. This will be equal to 3 times 4 over -5. So -12 fifths is our value. And for f of 2, we will have 3 times 2 squared over 2 minus 3. This is just equal to 12 over -1, so just -12. Now we have these 3 points here, these 3 values. We need to figure out the absolute maximum and absolute minimum. This is pretty easy because we need to do this by inspection. Our smallest value is -12. So this is our absolute minimum value. And our absolute maximum will actually be at this 0 value here. But it's the only non-negative number that we have. So absolute max. And that's our answer there. That wasn't too bad. Just going over this pretty briefly, it's important to remember the criteria for finding critical numbers. To find potential numbers, we need to find where f prime of c is equal to 0 and where f prime of c does not exist. Doing that will give us some potential values. In this case, we had 0, 6, and 3. But we must remember that these critical numbers have to lie in the domain of the original function f of x, and x equals 3 did not make the cut, because it would have made this have a 0 denominator. And then when we find absolute max and minimum values, it's important to remember the interval, -2 to 2 in this case. One, we must remember that potential values we found before, like 6, can lie outside the interval, so we can just scrap those. We also need to consider the endpoints of -2 and 2. And then from there, you just plug those into the function, the original function, you get your values, and just by inspection, you can see your max and min values. I hope this all made sense. Feel free to stop by office hours if you need some clarification.